Example number 3. They say if z is equal to 1/2 plus the square root of 3 over 2i, remember that's a number right there, that's a complex number, find z squared and z cubed. Holy moly, that's a lot. Alright, so now if z squared would be 1/2 plus the square root of 3 over 2i times 1/2 plus the square root of 3 over 2i, right? Because that's what it means to square something. Because this is z and this is z squared. You guys with me so far? Alright, so now what do? Multiply it out. So I'm going to use my grid. Now if you memorize, remember there's special patterns, like so a perfect square, if I square this, then add 2 times a plus b, and then square b, I'll get the answer. But we'll just write it out for now. So I've got 1/2 and the square root of 3 over 2i, and then I've got 1/2 and then the square root of 3 over 2i. So what's 1/2 times 1/2? 1/4. What's 1/2 times the square root of 3 over 2i? Square root of 3 over 4i, right? And then what's 1/2 times, hey, that's the exact same thing. Oops, I almost wrote it down wrong. I get that from Eric. So now what's this whole thing? It's the square root of 3 over 2 times I squared. So what's square root of 3 squared? 3. What's 2 squared? 4. What's I squared? -1. Do you guys see what I did there? Alright, so now let's write it out. I've got 1/4 plus, isn't that 2 of these? So couldn't I write that as 2 times the square root of 3 over 4i? And then what happens with my 2 over 4? It reduces. So this is really 1/2. Do you see how I did that? Alright, plus, oh wait, what's 3/4 minus, or times -1? -3/4. So to clean this up, I get 1/4, right, plus the square root of 3 over 2i minus 3/4. I'm done, right? No, remember that the complex numbers look like a plus bi, which means I have to begrudgingly add like terms. I got to combine those two terms because they're real parts. So that's -2/4, right? If I add that up, it's -2/4, which reduces down to -1/2. Now when Mr. Adams skips a step like that, if that confuses you, too bad. No, just let me know, okay? I want, you know, if you, I have to be careful about how we do that. Sometimes when you guys know what you're doing, it seems kind of silly to write out every step, right? And you're probably thinking, why does he make me write every step? I don't know why. These math teachers made me write out. So it's okay to skip steps, but some people like to write out every step. And sometimes they get confused if you skip steps. So I don't know. You guys need to let me know. Any questions all about this? Double check it. Is that the right answer? Are we done? No. We need to find z cubed. Nice try. Haha. So to find that, z cubed is equal to z squared times z, isn't it? So what is z squared? z squared is negative 1/2 plus the square root of 3 over 2i times z, which was originally 1/2 plus the square root of 3 over 2i. Now, does anybody recognize what this is? It's a special case. I'll get you started. Difference of squares. So there's a pattern, and now Mr. Adams sees he's going to have to go back and teach you what that means. But there's a pattern. I already know what the answer is. Do you guys know what the answer is? It's negative 3 over 4 plus or minus 1/4, so it should be like 2/4 or 1/2. That's the answer, is 1/2, I think, or 1. Right? Well, let's multiply it out and see. Okay. So if I have negative 1/2, we're going to multiply it out using our little grid, and then the square root of 3 over 2i times 1/2 and root 3 over 2i. 1/2 times 1/2 is a negative 1/4. Well, bam. This becomes negative 3/2 I, 3/4, or negative root 3 over 4. And then this becomes positive root 3 over 4i. And then this becomes the square root of 3 times the square root of 3 is just 3. 2 times 2 becomes 4. And then we have I squared, which is really negative 1. Now these two terms will cancel, right? Because this is positive, this is negative. If you add them up, it equals 0. So I really have negative 4 minus 3/4. If you add it all up, it becomes negative 1. Well, that sure did seem like a lot of work. Do you guys know what you're doing? Any questions? Cool.